Mealy and Moore machine, there are few things about them. The first thing is that there is no final state in Mealy and Moore because it's not accept or reject anything, because it's not accept and reject anything. So there is no final state. The second thing, Mealy and Moore both have same powers. Both have same power. And the third thing, the class of Mealy machine is equals to class of Moore machine. Class of Moore machine and vice versa. And the next thing, when output is fixed, we basically do it by Moore machine. Otherwise we can use Mealy machine. Now see how to make a Mealy machine to change the sign. So suppose we have this string 10110. So the first bit of that string is called the MSB, or we can say most significant bit. The first bit of that string is called MSB, or most significant bit, and this first bit is called sign bit, or we can say this indicate the sign of that string. So only first bit get change. It's only required. Only first bit get change. This is only required in change the sign when we are making Mealy machine, and remaining bit will remain same. So how we are going to make it? Q0 to Q1. So if we are having 0 then 1, we will get 1, and if we are having 1 then we will get 0 as output for first bit, and rest will remain same, 0 to 0 or 1 to 1. So as if we have this string, then first bit only need to change the sign. That's why for 0 we make 1 and for 1 we make 0, and rest will remain same. That's why for 0 to 0 output and 1 to 1 output. This is the Mealy machine for change the sign. Now move to next Mealy machine, in which divisible mod 3 is equals to 0. If we divide that string with 3, then the mod will be 0. If we are dividing something with 3, else what will be the remainder? 0 when it is completely divisible by 3, 1 or 2. These 3 will be the remainder if we divide a string with 3. So how we are going to make it? Start with the initial state Q0. We are going to make it with Moore machine. This will be easy for it. We are going to start with the Moore machine. This will be easy for us. So start with the initial state Q0 with 0 output. So for 0 loop and Q0 to 1 for 1 output, 1. So for 1 we are reaching on Q1, and for next state Q2 with 2 output. For 1 0 which is 2. For 1 0 which is 2 we are reaching on Q2, and if it is a 0 remainder then we are reaching on Q0. If it is a 1 remainder then we are reaching on Q1. That's why 1 as the output. If 1 0 2 as a remainder then we are reaching Q2 and 2 is our output. So 0 1 0 1 and 0 1 0 0 means 4. So because it is divisible by 3, so we are getting 1 remainder, so we are reaching on Q1. 1 1, so we are reaching on Q0 with 0 remainder. 1 1 which is completely divisible by 3, so 0 remainder, so we are reaching on Q0. 1 remainder then we are reaching on Q1, and 2 remainder then we are reaching on Q2, 2 remainder. That's why we are writing here 2 as an output, 1 as an output and 0 as an output. So 1 1 that is mean 3, so we are reaching on Q0. 1 0 0 1 again, then 9 1 0 0 1, then 9 which is mean by 9 in integer, so we are again reaching on Q0. 1 0 1 0 1, then again we are reaching on Q0 with which is 21, which is also divisible by 3. 1 0 1 0 1, so this is 21, so this is also divisible by 3. That's why we are reaching on Q0. So in the similar way, whenever we are getting a multiple of 3, so we are reaching on Q0. If it is giving us 1 remainder, then we are reaching on Q1. If it is giving us 2 remainder, then we are reaching on Q0. So in this way we can make a Moore machine which is divisible by 3. In the simple way we can say, when we get 1 we are reaching on Q1, for 2 we are reaching on Q2, and for 3, or we can say divisible by 3 completely, then we are reaching on Q0. So this is a simpler way, or we can say like this also. For 0 we are reaching on Q0, for 1 1 we know we are reaching on Q0, and for 1 we are reaching on Q1, for 1 0 we are reaching on Q2, and for 1 1 we are again reaching on Q0. So we can clearly see, whenever we are getting the multiple of 3, then we are reaching always on Q0. When it is 1 reminder, then we are reaching on Q1. When it is a 2 reminder, then we are reaching on Q2. So in this simple way, we can make divisible mod 3 is equals to 0 a Moore machine.